most run things, right? To get things. I mean, I don't know what. I mean, it could be everything. I hope it's not only structural ground state. That personally I find quite boring. But I mean, this is up to you. But in any case, the idea is that you have this ab initio way, right? So in general, people doesn't start from the physical object, but rather from the material. So I think that if I ask all of you, you barely know what is the theory you have to apply, because it depends on, you know, several things. But there is U, I mean, heavy material. You need a U interaction or whatever, but you perfectly know what is the material. Is a nanostructure, a surface, or whatever. So this ab initio machinery, of which Quantum Espresso and AIDA and Yambo are part of, is this machinery where you name the material, and then you feed something, and then it gets you the answer. So we are the jigs of this something, of the moisture. And actually, it's a moisture, because yesterday, the story was that the codes were just a part of your PhD thesis. It was, for me, the same. I mean, I started with Yambo because I just needed to do GW on the metals. I mean, the easy question was, I mean, I just had to do GW metals. There were no codes for metals. I mean, the only code I downloaded from the web was the one written by Godby, Rex Godby, and it was giving not a number on my metal. That's it. So that's the reason why there was a hole in I mean, I needed to do a calculation. I didn't have the tool. I wrote the tool. That's it. And that's it. You know, I mean, the coding is this piece, where there is one man, one code. So you write your code in that no user documentation, full of bugs. You don't care. I mean, the good thing is that you get PhD done, and that's it. Unfortunately, nowadays it's not like this anymore. So this is Yambo downloading, compiling. So there are millions of lines of code, and these codes, like Quantum Espresso, are layered codes. So it's not there is one man, one code. Okay, one man, one code. There are, like in the case of Yambo, 16 years of development. So it has been the first line of Yambo code that was written in 2000, when I was really young, and now 16 years ago. And in the 16 years, there were students. The same is for Quantum Espresso. A lot of students working on the code, maybe writing pieces. So it's a layer structure, very complex because of this layer structure. And I don't have time to explain to you, but I mean, now this layer structure is even made more complicated because Europe is asking codes to be more performant. So at the end of the day, I spend a lot of my time doing something I was not trained for. I mean, writing codes in a performance way, in a performant way, to run on those huge super machines and so on and so forth. This is another story. But it's part of the story, because you will see this afternoon, we will try to train you a little bit about the parallel structure of Yambo. You will see that it's not anymore to launch like MPI, run minus NP, 1 million, the code. No, you cannot do it. You have to be more clever, because if you want to run with hundreds of thousands of cores, you have to do it in a more smart way. So this is it's as important as GW. It's as important as GW. It's amazing. Okay, then how does it work? I mean, this is the DFT way. It's ab initio in a single slide. You get your system, you decide your Hamiltonian, this means your kind of potential, and so on and so forth. Then approximations, you feed your computer, and you get output things, out particles. But the point is that which kind of tool has to be solved here? I mean, Kohn-Sham equations, yeah, it depends what you're looking for. So there is this stairs to heaven of the methods. This is important. I mean, forget about Yambo, or forget about Quantum Espresso. Try to concentrate on the kind of physics you want to describe. So I know that you are under pressure, many of you is under pressure in publishing and get a CV, get a position. But if you have a system with d orbitals, don't apply LDA, please. Think about it. So don't try to float PRB of papers on materials with d orbital done with LDA. Think about it. Think whether the tool you are using is the most appropriate to the physics you want to describe. So if you want to do materials with d orbitals, don't download Yambo. It's useless. Don't do it. Yambo does GW. So not T-matrix, no fancy U interaction. Try with LDA plus U. So maybe you can try quantum espresso, but be careful because, I mean, study, because it could be that the result you get is nonsense. Or, I mean, you cannot compare to the experiment. So think about it. So depending on the physics, we are interested in gaps. That's fine. So we can use many body in the flavor of Yambo. But already, if you want to set a system with upper bands, no GW. GW does not describe upper bands. Yambo doesn't give upper bands. So no upper bands. If in the experiment you see a metal to insulator transition, no. Accidents. Yes, Yambo, it's okay for accidents. You can use it to calculate accidents. And then you want to meet your colleague near office tells you, oh, I have very beautiful experiments of pump and probe, ultrafast spectroscopy. Can you calculate it? Okay, with Yambo, you can, even if not in a GPL version. But that's even more. It's not many bodies. It's not an equilibrium Green's function. It's more complicated. So there is, the theory there is. There are other people studying theory, but not all the theories are in codes. So it could even be that the tool you need is not written, and then you have to write it yourself. So the situation is complicated. I mean, if you look, I mean, this is one branch of physics. Is the thing I'm working now on. Is this out of equilibrium, whatever, blah blah blah. But it's really a fight of titans. I mean, between different codes and theories and so on and so forth. If you look at the kind of the whole world of observables, you see that the different methods have different range of applicability. So, for example, when you go out of equilibrium, GDFT remains stuck in a very limited part of the spectrum of things, of physics involved. Then there is many body and models that are, I mean, can be produced to describe everything. So it depends on the kind of physics you're interested in. So what is Yambo? Yambo is not quantum espresso. So it's completely different. I mean, there is nothing sharing between them. I mean, we are both on the same repository. So we are hosted on the same QE4 repository, but that's all. Then, of course, now we are, of course, it's not all. I mean, we are part of the same H2020 project at the moment. That is the transition to the exascale world. I will tell you briefly about that. Okay, so being a very complex code is very modular. Why I'm telling this now? Because I told you that if the tool is missing, maybe you have to write it yourself. Well, especially because neither Quantum Espresso or Yambo are single-man, single-code codes, and they are very modular and very layered. They offer a platform to do coding. So this means that if tomorrow you want to code, I don't know, I have an example. I have an example for you, Raman. There is a student in Luxembourg that wants to do Raman with many body techniques. He's doing with Yambo. It's okay, because Yambo, like Quantum Espresso, gives you the bricks. I don't know, Yambo can give you the Green's function, or can give you the quasi-particle energies, it's just as an output. So if you run Yambo, at a certain point somewhere, you get some information, so like the Green's functions, like polarization function, and then you can use, for example, Raman is a displacement-dependent response function. If you get the response function for several atomic displacements, then you post-process it, then you get Raman. And then, of course, Yambo gives you frequency-dependent response function. You can use it. So this means that even if you want to study, I don't know, d orbitals or fancy charge carriers or whatever, and there is not, at the moment, the theory in the tool, you can think about using Quantum Espresso or Yambo, depending on your needs, to do your piece of code. It's not impossible. So that's in the word collaborative. But there are other keywords of modern codes, including Yambo. You have to be part of communities if you want to evolve. You have to communicate and to do training to people, to users. Users take a big role in all the Yambo story, and you have to think about performance. Okay, the story. 2004 versions. We are in 2017. Before was named with the name I gave while I was doing my PhD. And then it turned in Yambo in 2009, where it turned also in GPL. So at the beginning we were 4, and then now we are many. We are many. And we even have a T-shirt. But if you want a T-shirt, you have to write at least 1 line of code. If you want 1 line of code, you get a T-shirt. Yeah, and it's written type Yambo developer. I'm very proud of this T-shirt. Okay, then, okay, I don't want to describe more. I mean, modular means modern codes are modular. So modular really means like a machine, like a car, like an engine. So you have transmission, your engine, gear, and so on. I mean, all separate parts that you can remove it and take it. This is very important because I mean, it takes. I mean, it took me as much as time to learn non-equilibrium Green's function to learn how to be modular. It's very important. Why is this? Because if you build an enormous skyscraper, right, a big building, enormous, you don't want dependency to be, I mean, unless the internal structure, you don't want other dependencies to be very global. So you don't want that a guy to the 100th floor does electricity contact, and then all the electricity, all the building goes away. The same is for code. You cannot develop a code that has global dependencies. If you touch one line in one place, then explosion. But this means you have to be very modular. So whenever you have something that is repeated twice, you have to take it out and make it a module, and so on and so forth. And Yambo is pretty modular. And it's very user-friendly in the sense that if you want, a nice thing I always say that if you search in the Yambo code, there's 100,000 lines and so on and so forth, you don't see a Fortran write. There is no Fortran write. All the writing is done by a module. So if you change a module, all the code will write in a different way. This is very, I mean, you see, it's so important. It's so important. I mean, you can imagine. I mean, if you at some point you want to know to step from plain Fortran to netcdf, changing all the I/O in the code. If it is modular, it takes a week. If it's not modular, it doesn't take. I mean, just you don't do it. Okay, so it's like a tree. Yambo is like a tree. You will see this afternoon. So there are run levels. Whenever you calculate something, it's like in this big tree entering a branch. You are in the main trunk, then you enter a branch, you exit from a branch, you enter a branch, you exit from a branch. Every branch is GW, response function, BDSRPeter, TDDFT, adiabatic LDA, and so on and so forth. Okay, dissemination, we have schools. I will give you the announcement about the school of this year, all over. This was in Africa, where I met some of you. In South Africa. And you have a web page, forum. So if yesterday was a one-man show, now all codes are community development. This is very important. So this was this is the T-shirt and the announcement for the school of 2017. And that's all.